So I wanted to show you with graphs what these three things look like, so you can see they mean the same thing. So here's a graph of some function. Kind of looks like a hyperbolic sine. You don't need to know what that is, but it's kind of what it looks like. And I drew in these kind of really faint horizontal lines to represent like a horizontal line that you're kind of sweeping across from the bottom up. You're looking at all the horizontal lines that intersect that graph. And you're asking yourself, does it pass the horizontal line test? In other words, do any of those horizontal lines or any of the horizontal lines in between the ones I drew, do any of those intersect that graph twice, right? And you're just sweeping up from here. You're just sweeping up all the way across here and seeing if any horizontal line intersects it twice. And the answer is no, right? So does F pass the horizontal line test? I'm sorry. Yes, it does, right? It passes the horizontal line test if no horizontal line intersects it twice, okay? And that means F is 1 to 1, right? If you have two different inputs, you get two different outputs. Just think of it like this. So say you have an input here and you have an input here. Well, their outputs are different. That's what 1 to 1 means, right? And I drew the inverse graph in F inverse, and you can see that's a function. How do you tell that's a function? Well, first of all, that's the theorem that that was actually a theorem that we had on the previous page, the equivalence of the three. So F passes the horizontal line test, so F is 1 to 1, so F inverse passes the vertical line test. Why is that? Because when you switch X and Y coordinates of F, you're switching the X and Y, and that changes the horizontal lines, which are like y equals 0, y equals 1, y equals 2, y equals 3, y equals 1.5. You know, those are all horizontal lines. It changes those to vertical lines, x equals 1, x equals 2, x equals 3, etc., you know. So here I drew them in. So the blue lines become those little, whatever they are, kind of flesh-colored pinkish lines, right? And the blue lines are related to the black curve F, and the pinkish lines are related to the red curve F inverse. And you can see F inverse passes the vertical line test, right? Which means that F inverse is a function. See, so this is just a demonstration that these three things, passing horizontal line test, being 1 to 1, and the inverse being a function, are all the exact same thing. They always occur together. Here's a kind of a parabola, parabolish. So F here fails the horizontal line test. See, every line I drew there actually intersects it twice. If a single line intersects the graph twice, horizontal line intersects the graph twice, it fails the horizontal line test. And we've got infinitely many of them. I didn't draw them all, but we've got infinitely many. So therefore, it's not 1 to 1. Okay? You can tell that. I mean, look, what does it mean to be 1 to 1? You'd have to have every input have, like, only one input give each output. So, but you've got this input that gives this output, and you've got this input that gives this output. Right? So it's not 1 to 1. And that means F inverse is not a function. It's a relation, it's an inverse relation of F, but it's not an inverse function. Because it fails the vertical line test, see? Everything gets turned sideways. It's a simple way to think of it. It gets turned sideways. It fails the vertical line test because F inverse fails the vertical line test because F fails the horizontal line test. Right? So F inverse is not a function. So that's just showing you an illustration of that theorem that I had, that those three things are the same. Passes the horizontal line test, 1 to 1, and the inverse is a function.